So, welcome to the session here. My name is Mark Adams. I'm the safety engineer with Environment, Health, and Safety. I'm with the group that puts all those annoying stickers next to the door that say occupancy is. I just noticed we have one on the door here.
It's 49.
49, so we're good. In fact, there aren't even 49 chairs. So if you look at a lot of these stickers, it looks like you could pack the room like sardines. I don't quite know how we get to those numbers. Any rate, everybody here should be in a club and be either an officer or a safety officer of that club. And we're doing a session to go over safety stuff to allow you to work in your lab spaces. So, and I add here, or I mentioned, don't add safety, build it into your job. That's kind of going to be the theme of this presentation. And for the guy that's going to be working for Lockheed Martin soon, you'll want to really listen carefully. Just saying. So, this is an acronym that is real prevalent in the building trades and construction industry. Anybody know what it is? Probably not. It's prevention through design. So, what we're trying to do, and maybe I'll take a step back here. So, what we're going to go over is not exactly what you think. You might think I'm going to be up here talking about how you're exactly going to do the safety stuff you need to do in your lab, but we could spend 6 or 8 hours on that and you'd be completely bored, and so would I. So instead of that, we're going to go over more of the thought process of how you make the laboratory safe, how you make your processes safe, and how you learn what you don't know, and how that all relates to your interactions with the rest of your lab staff, club staff, however you term those people. So prevention through design is the thing, and that's what we'll go over. So I always try to add a little street cred to this. I was in your position once. That's me in 1984-ish, running the 2 megawatt nuclear reactor we used to have on South Campus. That was my job as a student. And it was until 1994. And I'll tell you what, that was a great fun job to have. I'm also a licensed PE, and I'm going to give a pitch for that shortly. And I'm now the safety engineer here with UB. Oh, and a few gratuitous photographs. There's the reactor running at 2 megawatts. If you've been by South Campus, you might recognize that in front of Kapoor Hall, right at the bend in Rotary Road, there's just a big grassy field. That's where the reactor was. Oh, and there it is being constructed. Just extra cool stuff. Oh, and the quiz for today, there's no grading, but I will give a quiz. Anybody know what that building is? Do you guys ever get to South Campus? Ever? No? Not ever. Okay, that's Kapoor Hall, School of Pharmacy. It's been rebuilt, doesn't quite look like that. Oh, and the building in the background is Carr Parker Engineering Building. That's where I took a lot of engineering classes back in the late 70s before the stuff got moved out to here. And one more gratuitous picture. And to prove I've been here that long, it even says in the newspaper I've been here nearly 40 years. So there we go. It's gotta be true. So, what do I do and how does it relate to what you might be doing? Well, there might be some construction safety planning, building a bridge, building a car, building a rocket, building anything. You've got to obviously plan to do that safely. You might have to manage a safety program. I know the people that are in the Chem E-Car group, I don't know if there's any of you here today, yep. You have protocols which are actually right from the organization that runs the competition. So this stuff is like built right into what you do. That's fantastic. That's what you have to know how to do when you actually have a job making stuff, especially at Lockheed Martin where you got a lot of stuff that can blow up. I'll just keep picking on you then. I do a lot of fall protection work, accident investigation, the DigSafe coordinator on the hazmat team, lab safety inspector, we'll get to that shortly too, liaison with student clubs, and I'm the drone czar for campus. So, and consultants to a bunch of other projects, which we won't go over, but you can see that a lot of those things fall under, in general terms, what you do as a safety coordinator in a club. So, there's this really famous engineering book which you've probably never read. It's really boring, but on the first page, Professor Marshall pretty much says that there's one area that's kind of lacking in general university education, and that's the safety aspect of engineering, which is built into the tenets of engineering from, right up through the National Society of Professional Engineers. So, what do you need to know specifically? Well, you need to be professional about what you do. Okay, it's the competence or skill expected of a professional. You also need to be the competent person on those jobs that you do in the club that have some safety aspect to them. So if you're mixing chemicals, if you're welding, if you're cutting, you're grinding, all of those things have some safety related aspect. And what we don't want to do is think about how we take care of that after the fact. We want to build the safety stuff right in. If you start working on something and you say, oh man, I probably ought to have safety glasses on, that's kind of like the wrong way to do things. It should be just a natural thing. You just build it right in, you do it up front. And if you have specific protocols on how to do things, job safety analysis, that kind of stuff, frequently you'll have, that'll be there up front. It'll be the PPE, and that'll be the first steps. So the competent person, as far as OSHA is concerned, is pretty much as far as it is in a club atmosphere. So it's a person capable of identifying existing and predictable hazards, and most importantly, it's the person who has authority to take prompt corrective actions. So when you see somebody that's operating the grinder, they don't have safety glasses on, it's your responsibility to have them stop, take a step back, remind them they have to have their PPE on, and then move forward. If you see that something, like there's something that's put up on a table, a concrete canoe kind of thing, and it looks like it's about to fall over on somebody, it's your job to make sure that, hey, let's take a look at this, let's make this thing stable. We don't want anybody to get hurt. We want everybody to go home with the same number of toes and fingers that they showed up with, and eyeballs. Here's my pitch for the PE Society. I would suggest everybody, in your senior year, if you can, take the professional engineering exam, the fundamentals exam. I can tell you from my standpoint, I took it 10 years after I graduated. You can't even imagine how much chemistry you're going to forget in 10 years, or how much physics. It's you know the stuff you need to know for your job, but everything else kind of it's like radioactive decay. It kind of goes away. So I would strongly suggest taking the exam, even if you're going to work in an industrial setting. So like if you work for a company like Lockheed Martin, they're under an industrial exemption. So is a place like General Motors, or go to work for Tesla. They'll be broke soon. But I could spend an hour on that one. So any rate, they have an exemption. You don't need a professional engineering license. But the way things work these days, most people have 3, 4, 5, 6 jobs over the course of a career. You might start your own company, and especially if you do that, you're going to want to have the right credentials. You're going to want to be professionally licensed. Yes.
So does that mean that there don't have to be PEs on staff because the industrial? They don't have to be.
That's correct. They don't have to have, because they wrote the exemption in, and the theory is that there's enough layers of management and control over what's being done, and if you're producing a product or a service, that you're going to have the appropriate level of insurance, and that's going to drive the safety of the thing you're making or the service you're providing. And for the most part, that works pretty well. Most companies are pretty good with that.
It's really very market driven.
Yes, yeah. If you produce something that kills people, it doesn't work very well for you. You're going to be out of business. So, what skills are you going to need to do this job? Well, clearly you need the ability to recognize hazards, and that is in design and construction and in operation. And this is the one that mostly gets forgotten. So prevention through design, you're building the thing. And I'm gonna use a lot of architecture examples here because we have a lot of problems at the School of Architecture, more so than here in engineering. And they're really good at sending people to the hospital on a regular basis. And I have some blood and guts in here to show you too, so spice it up. But it's really important you think that far ahead. When we run into this, it's really common. We hire architects to put up a new building. And we could go over to Davis Hall right now on a little tour. And you walk into the mechanical room and somebody decided that valves that we need to someday work on and replace are 35 feet in the air with gigantic ventilation ducts in front of them, girders, pipes, steel structure, and I can't get to that. How is the guy, now it's my problem. How am I gonna get the guy from facilities on a lift or a bosun's chair or whatever to just work on the packing on that valve? It's impossible. They've just completely, they bonked on the whole thing. And it's like a case study in how not to build a building as far as the operational aspect. Of course, if you're the architect and you just want your fee and you want to move on and you don't care, you just build it and off you go. But you don't want to do that, especially your friends. So if you design something that's going to break somebody's arm, it might work great, it might look great, you might get a good grade on it, but if you can't operate it safely, then not so good. This is a really popular concept. Everybody likes to use this thing. You don't know what you don't know. And it's especially true in the safety business. Don't like the cameras. You can't know everything. You can't be a subject matter expert in everything you do. But what you have to do is find a way to ask the question when you need to. So if you're doing a process and something looks a little unsafe, you're a little unsure of how to do it, that's a good time to step back and say, are we doing this right? Maybe ask your professor, maybe call me, ask a club advisor to find out what you don't know. So all of this safety stuff is driven by laws, codes, standards, letters of interpretation, and best management practices. All this stuff is readily available to you. So if you would like to know, if you're mixing concrete and you see the bag of mix says contains silica, inhalation, lung hazard, it's cancerous, and you're gonna mix the stuff up, you might wanna take a look. What are the laws, code standards, best practices? How do we handle this stuff? And many times there's the hazard label is way overkill. It's meant for somebody that's doing this job, 5 days a week for 40 hours, and they're, highly exposed to it. And maybe the answer for you is just mix it outside. Problem solved. There's a lot of examples like that. A lot of people will go with it's just common sense, I need to do it that way. But if we were to go and look at any particular job hazard analysis, steps to do something you need to do, and I said, okay, let's take this thing and let's all write the 5 steps we need to do this, we'd all come up with generally things that are different. Because what you think is common sense to get the job done might be completely right, and the way I want to do it might be completely wrong and unsafe. So common sense is not so common. So we're not gonna use that as the basis for how we're gonna do this. So, like I said here, what are we gonna do with all this information? Oh, there's our 2 quiz items. Anybody know what that building is? No, that is the nuclear reactor, which is now gone. That's Veterans Hospital in the background. I'm sure everybody knows where that is. And for the next little piece of trivia, in case you need to know, does anybody know the name of the golf course next to Veterans Hospital? Somebody must.
Amherst something?
It's Grover Cleveland. It's Grover Cleveland Golf Course. And it used to be the Country Club of Buffalo where they played the 1912 US Open. No? Anybody? No golfers? Well, I'm really striking out here. So, topics for your club, things to consider, things you might need to know. Fall protection, if you have, if you're using ladders, even step stools, it's really worth going over that with people that are using them. Life safety generally refers to fire safety. Do we have the right fire extinguishers, extinguishing material? Do we all know how to use that? Are there enough? Are they properly placed? Did we take it with us for that operation that's outside? Hazardous materials. Most of you don't work with hazardous materials. You might, on an off chance, produce hazardous materials, but I've generally found that that's not the case, so that's good. That's a whole separate hour-long training, which if we can get around it, we will. Mechanical and electrical hazards, we're going to go over examples of all these issues. It's always good to be cognizant of those, wearing your PPE and operating things safely and make sure cords are in good condition, all that sort of stuff. Materials handling and storage, we don't want to be piling bags of heavy stuff high on cabinets that are unstable. Want to make sure everybody has, again, proper gloves, safety shoes if people need them. At least not wearing flip-flops when handling heavy stuff. And shop operations. There's a lot of issues related to this, but tools need to be in good condition. We want to make sure people have enough room to work around that tool, have proper clearances, those kinds of things. Ergonomics is something you won't usually get into, and personal protective equipment, probably the number one thing we need to be concerned about. And that's typically going to be safety glasses, gloves, hearing protection at times, and not respiratory protection, which we'll get into here very shortly. So, there'll be some gory stuff. It's really the best I can do on the gory. So a lot of examples of things that have gone wrong in a club or shop setting with students. That is blood, and that is a box cutter. So it turns out that architecture, you can imagine, they use a lot of knives. They're cutting a lot of foam, a lot of balsa wood, a lot of soft materials, and they have every manner of knife you can imagine to saw stuff up. They also give a 15, 20, 30 minute, I've never actually been to it, training session on how to safely use those knives. I'm not sure whether this kid got the memo or not, went to the training, but clearly his common sense did not prevail. He thought he was doing the right thing, cutting this package open, and ended up with 10 or 11 stitches instead. So there are very simple things which you do on a regular basis that you probably don't even think about as being very dangerous or hazardous. This would be one, just grabbing your knife, opening a box, cutting a cord off, but they can be quite hazardous. Here's a design, prevention through design thing. This looks pretty good. It's a set of stairs at Farber Hall, and well, it's not a club thing. It's something you might do. So you specify something that looks good. You're gonna put this railing in, and that's good. And you take a look and you see, oh, it meets the building code. We have the right dimensions, the right sizes. It's the right strength. Okay, that looks great. Let's do that. Then what happens is the first person comes by through this door on the first rainy day, grabs onto that railing, and takes a dive on the stairs. Why? Well, we never considered the grip coefficient of that railing. Everything else was perfectly good. But you know what? There actually is no code for the grip coefficient. It says in the code, must be sufficiently grippy that you don't slip. Well, what does that mean? Exactly. How do we figure that out? It's not like, we can take this railing, put a little water on it, and take another piece of material and run it across and, measure the force and see what the coefficient of friction is. We can't do that. Well, we could do that, but to what end? The code doesn't say, doesn't give us a number. We don't know. It just says it must be appropriate. So there's a great case of the facilities person called up the guy that supplies the railing, told him we need a railing. They came out, they confirmed all the dimensions, everything's great, but the finish on the railing was not considered. Here's another classic example of something that can go wrong pretty quickly. Does anybody know where this is from? The last group knew, just to put the pressure on. Yes, furnace. You know what room? The last group, 2 people knew the room number.
5th floor?
Yes, 5th, we'll take that, 5th floor.
Yeah.
So, here's a situation where this furnace, you can imagine writing the accident report was terrible. My spell checker kept wanting to do the other. So, this looks pretty good. They run this furnace, they've been running it for years. And one person would come over from chemistry and she'd have her little boat of chemicals and she'd put it in there and she'd stick it in there 500 degrees C for 5 or 6 hours, and she was cooking it for some reason, bake off moisture maybe, I really don't know what it was for. It was perfectly fine. She'd take her little boat of samples, run back to chemistry and do her thing. Why she wasn't doing any chemistry, I don't know. Then the next person comes in, and she's from down the hall on the 2nd floor, and her experiment goes in, and it's supposed to go in for a couple hours at 200 degrees. Well, you can imagine, if you've worked with any of these before, programming that is no easy task. The interface, terrible. The lights and what it means and whether your program is actually in there properly and did you get the temperature and the ramp right, it's all very confusing. Even on a brand new one where the cover hasn't been blown apart. So she put her experiment in, thought she had the right time and ramp, and she left. Well, there were a bunch of guys sitting in the other side of the room there when they heard this thing explode. And what exploded was this stainless container which had the methanol in it. And of course, when you look back on this, you realize methanol has an auto ignition temperature of just a little bit less than 500 degrees. And that's what we think what happened. The methanol let loose, it turned that bomb. They call these acid digestion vessels. They're actually called bombs in the literature. Turned it into a bomb, and it rocketed right up to the top of the furnace, blew the door off. Ceramic powdered material from the insulation was everywhere. It was quite the mess. Really lucky nobody got injured or killed. So there again, you have a person who's maybe a little less familiar with the equipment than they should be. They weren't formally trained how to use it. They never confirmed they got formally trained. They're just kind of like taking a stab at it. And they're not using a nice big instruction sheet, they're just using something they downloaded on their phone, so maybe maybe the PDF didn't size right, maybe they didn't quite, read it properly, don't know. And you end up with this problem. To make matters worse, instead of buying these acid digestion vessels from this company, whose name I can't recall, they bought them on eBay. And the manufacturer in Hong Kong doesn't exactly state what the full specifications of this thing are. They state they're kind of like the ones you get from this company, only cheaper. And so specification of materials is a big deal. You don't want to be buying the wrong thing. I mean, if that's the thing you needed, great, but generally not. One thing we need respected here at the university is our facilities, everything that's kind of like built into the building. We don't want people modifying things. This is especially true with electrical stuff, and over in architecture, they're really good at taking switch plates off and wiring their own stuff up to extend things for whatever purpose. This is actually one from electrical engineering. If there's any electrical engineers here, you might see what's going on. So they decided that they needed an extension cord. And, well, hey, we have this, oh, they needed an extension cord for, it was 220. So they had this properly rated NEMA plug here, and they had this insulated cord, but what they didn't have was the mating end for the other part of the job. And of course, if you go buy these, these are like $30, these cord ends. They're very expensive. So they probably figured, hey, we'll just use what's laying around. Hey, this says 220. If we take a Sharpie and write 220, it's 220, right? Yeah, it must be. So you plug this thing into the 220 line, and you leave this dongle out here to plug your 220 thing into, which you've now converted to a 120 volt plug. This is great as long as you don't plug something that's like your brand new Keurig machine into it. Because once you let the smoke out, it doesn't work anymore, assuming you didn't get injured in the process. Not to mention the very, very poor technique of not running the insulation into the back shell of this connector. I don't know whether this is a you don't know what you don't know. Nobody would fess up to doing this. They wouldn't, although it was plugged in when we found it, they wouldn't even say what they were using it for. We never found out. But clearly it was being used. So it could be you don't know what you don't know. It could also be I didn't want to spend $30 and I made some piece of crap up and tried to make it work. Yes?
Where was that found?
Bonner Hall. Bonner, second floor, one of the labs. This was found down in architecture. A bunch of students working on a project, and apparently their string of lights the cord had a break in it, whatever. But they had another cord that was also broken, and they thought, well, we'll just put this together and we'll just make our own. So they homebrewed a nice connection here. They found some wire nuts, a little bit of tape, and there you go. Well, the first accident I investigated working for Environment, Health, and Safety here was from an electrician who was working on a lighting circuit. And above the ceiling was something exactly like this. And it was in a place he couldn't see. He was going to pull the wiring out so he could look at it, and he thought it was dead, but he couldn't really reach it to test it, and he thought the circuit was off, but of course, there's always one circuit in there that's live. You can't get them all normally. And when he went to pull the thing out, his finger grabbed the back side of the wire nut. And of course, the person that did this, at least in the building where he was, failed to cut the insulation off at the right length. So instead of having, a nice 3/8 of an inch of copper sticking out, there was 3/4 of an inch. And of course, it was 277. It was hot, and he grabbed onto it, and that caused him to fall about 4 feet off a ladder onto his back. And he had a nice 6 months vacation at home. And I can attest, after talking to him at home about a week after the accident, he was screwed up for a while. He said, I can't take any more Oprah. I can't watch it anymore. He was dying to come back to work. So another good reason not to get hurt. This fire investigation was interesting in that this is not too dissimilar to what might go on over at SAE or in any shop where you have machining. And one thing you need to be cognizant of is shavings of metal, but not just metal, aluminum, titanium, or any specialty metals you might be working with. They can be a real problem, and they were here. This is not an engineering shop. This is actually the machine shop over in the School of Medicine on South Campus. So on one day of the week, the guy is working on making a joint for somebody, and they're machining titanium, and they get all the scraps and they put them into the waste container, and all good, kind of. The next day, his buddy goes and he's going to put a piece of metal here on this vise, and he's going to take the grinder and he's going to clean that up so he can weld it. Well, sparks into a bucket full of titanium shavings is a real problem. It gets very exciting very quickly. And they expended 6 or 7 fire extinguishers. They were both volunteer firemen, thank goodness. They knew instantly that they weren't putting the fire out because they had no Class D fire extinguisher. And they knew the only way to put it out was to spread it out as far as they could. Yeah, Buffalo Fire, when they got there, was not very happy. The fact that they could have lost the building. So a lot of little things. So there's a great lesson in housekeeping. And this can happen, oily rags. You're working on a vehicle and you're wiping things down, they're full of oil. You just throw them in the garbage can. That can be a real problem. They should be in a covered metal container. This is another prevention through design kind of thing. So we had one fatality in our facilities group, 2002, and it occurred over in Crosby Hall in a steam accident. And this is a case where you do the same thing every single time you do it long enough, and pretty soon you're just you're just doing it that way. You're not thinking about it. You don't second guess yourself. You just, I did it this way last year, I'm doing it again this way this year. And what this guy had to do was come into this room, we start up the steam plant, we ramp it up to pressure and temperature, and then each building in turn gets its steam station turned on. So they open the valves, they let steam through very slowly to warm things up, and eventually everything's full of steam and things are working properly. Well, steam has some unusual properties, as you may know, in an industrial setting. And if you get it such that you hear that the typical water hammer of steam in a steam line, that means you've got water somewhere in the system. And that water is being accelerated and it's slamming into something. In this case, it was slamming into this T at the end of the run. So this pipe chase goes back to the steam tunnel. This pipe goes straight through to the tunnel. Of course, we found that it had a sag in it where water was collecting. And as they started up the steam system, if you started it up too quickly, you could get significant water hammer. And the water hammer was enough that it took the flange on top of that T and it just busted it. Well, the part of this that is really unfortunate is you just do things the same way every year and don't think about it. So the way you did this job is you went here, you climbed up on this railing, you climbed up on this platform, and you operated these valves in the overhead. And it takes time. Getting a steam system started and up to temperature might take 5, 6, 8, 10 hours. It's not a very slow, it's not a fast process. It's really boring. And the temptation is to open the valves a little faster, open them a little more, to the point where I hear the water hammer's a problem, let me close it down a little bit, and you play this game with it. Well, the issue here was not only that, but the fact that the guy was up here on this platform, and of course, when the steam line busted, there was 125 PSI. The boiler plant was running full bore. It filled this room up with steam. 125 PSI is about 370 degrees. And when you start condensing that, basically you're in a fog of boiling water. And the guy was killed. So, hindsight's 20/20. You want to design something safely, you put it where you can reach it and where you can get out the door if you need to. And here's the new setup. Why in 70 years we didn't think of this is kind of a mystery. I mean, there were hundreds of people that operated this thing, and somebody should have recognized that it was a real problem. But again, maybe in 1929, that's the way you did it. And that also brings up an interesting point. So the T that I showed you that cracked, when we looked at the specifications, they were correct. It said that these pipes and the fittings were all supposed to be ductile iron. which was the standard of the day, and if it was ductile iron, it would have lasted another 70 years, no problem. Unfortunately, what got supplied, because we tested it, we sent it to a lab, they turned them into tensile test specimens and sharp UV notch specimens. They tested it, and we found out it was very brittle. So it was an accident waiting to happen. Here's a case where the right material was spec'd, the wrong material got delivered and installed. Just another case of things going wrong. Here's a constructability thing, which you might run into. You always want to make sure the things you're constructing can be constructed safely and used safely. So, another architecture example. This is really kind of cool. You see this cord, this runs back into the building, and that cord was so they could run their electric drill motor, which is right there, with a bit that was about that long. Because they had to drill through these cardboard mailing tubes so they could put the all thread in, so they could put it together to make the geodesic thingy-mabob. Well, whole pile of problems. So when you work outside with electric equipment that's AC and it's cord connected, it has to be on a GFCI. Just, it has to be, that's the electric code. This was not. And to top it off, the person that was doing the drilling was standing on the aluminum ladder, a double whammy. And then they were standing on the ladder drilling, and when I saw them, I almost crashed my state vehicle driving around the corner. The guy's standing on the aluminum ladder. He's got this big drill in his hand with the bit this long. He's drilling down into the very top of this geodesic structure to drill a hole, while the person below is holding the mailing tube in position like this. Like that, literally like that. I mean, he could have drilled right through their eye socket. It was quite the sight. When I spoke to the professor, they had no idea. I asked if they had a work plan, whether they discussed this, whether there are any safety measures that were discussed prior to building it. Nothing. They had the mailing tubes, they had the materials, they were told to build it. And then to top it off, they left these hazards all over the place. 3-4 inches of all thread sticking out everywhere around this geodesic dome. All it would have taken was one person to trip and fall into the structure, and it'd be like a horror movie with the all thread in their eye socket. And nobody had safety glasses on to do the drilling, especially the person that was right underneath the mailing tube. That was quite good. Here's another case. It's kind of a materials and constructability thing. A track coach decided they were going to build a nice new setup for the track athletes to do their exercises. And of course, if you buy the stuff like you see in a gym setting, it's pretty expensive. Why is it expensive? Because somebody actually designed it. They figured out the materials have to hold a certain amount of weight, forces in these directions, the right gripability of the surface. All this stuff is taken care of. It's designed in, just like new playgrounds are fantastically designed. Or you can take your track kids and you can go to the nearest Home Depot with a couple $20 bills, and you can just buy stuff that just kind of does the same thing. Kind of does the same thing. So the question I had was exactly on these flanges here in this pipe. What is the ratings for those? Did anybody look at the shear forces on those bolts? What are they going to pull out at? And what's going to happen over time? Because you could see this material had been there for weeks and it was already starting to rust. So is that something you're going to go out there and be doing exercises on those parallel bars? Well, you might. They were doing it. Unfortunately, it all needed to be cut down. So again, another nice try, saved a few dollars, kind of. Safety data sheets. These are a must-have when we have fire inspections by our state fire inspector, they look for these in the labs. And they're gonna wanna make sure you have a couple things, that you're not over the flammable loading limit for your lab. And generally that's gonna be, or your shop, that's gonna generally be 10 gallons of flammable material. That's the max in any room on campus. As you go higher up a building, it's even less. By the time you get to the 10th floor of Furnace Hall here, you're down to like a squirt bottle of flammable material. And these safety data sheets are good for a couple of things. And most people never read them. They get the stuff in stock, the data sheet goes in the book, and it goes on the wall. But I'm gonna make the pitch that if you really wanna read one section of the data sheet, read the first aid section. That's really important. A couple of years ago, I was at Natural Science when I heard the call on the radio for a chemical accident on the 5th floor. I was literally the first person there as a first responder, and I got off the elevator and I could hear the screaming down the hall, which is not good. When I got to the lab, the screaming was because it was the middle of February and they had the guy who got splashed by this acid, and there were a couple of his lab mates were holding him under the sink and they were hosing him off with cold water. And you can imagine with how cold the water comes out of the tap in the middle of February. It's pretty cold. And I walked into the room and somebody handed me the data sheet. It was like the first thing they did. They had it in their hand. They handed it to me and said, see, we're doing the first aid steps here. And it says, put them under as cold a water as you got for however many minutes it was. It was like perfect textbook. Had they not known that or known what to do, the guy could have been significantly injured. So knowing what the hazards are for the chemicals you're handling, you may think it's completely innocuous, but all it takes is for one person to mishandle it, slip or fall, get it on themselves, and that first aid information becomes vitally important very quickly. So if you're the safety person, it would be good, especially if you're doing something new for the first time, maybe that's the first 5 minutes of that particular work session, go over the data sheet. If you have any gas cylinders, please secure them. In physics, they'd like to just hang the straps there, kind of make it look good. Throw physics under the bus. Okay, getting down to the end. A lot of people like to fly drones. I'm sure many of you have them. I know there's at least 5 or 6 labs I've seen where there's lots of drones. A couple of labs with nets, which we're in the process of actually, hopefully, very soon having a netted facility outside on their side of campus here. It's like 60 by 60 by 200. So people that are doing research can have a place to fly that's outside but large enough where flyaways won't be a concern. So we have a program that we need to follow. We also have New York State rules. There's also new FAA rules which are coming out, should be effective in about 3 months, which change quite a few of the things we have going. So if you're going to fly here on campus, please take a look at the policy. It's at the facility's website. If you just go to the UB, but if you go to buffalo.edu and you search for drone policy, you'll get it. It's in a couple of places. And take a look. What we've done is we've designated a bunch of spots on both campuses that are what we call safe fly zones, that if you're flying per the rules, just fly in the safe fly zone and have at it, with one little caveat. Both North and South Campus are within 5 miles of the Buffalo Airport, so all flights have to be approved by Buffalo Control. And there are a couple apps that will do that for you automatically. Or you could just call the control tower, but they'll tell you to use the app. I know it's kind of a pain, but that is the rule. Here's the safe fly zones. You can see we're kind of about right there. So there's a bunch of places to fly. And some of these are actually a little bigger than it kind of looks. This one's really good, right here by the tennis courts over by Ellicott. That's a really big field, and got a lot of room there. Again, here's the 5 mile outer ring. Unfortunately, they couldn't put the darn campus, just a little over there. We've been very helpful. If you use one of the apps, you'll get one of these fancy notices of authorization. This is mine for last Thursday to fly down south. We were taking some, I think that was for photos of buildings for the facilities website. And some drone resources. The app that I use for the flight planning is Skyward.io. Works really well, and they'll give you instant authorization for Buffalo Airspace to fly. Lastly, one slide from lastly, if you have any questions about any of this stuff, if you're looking up like rules, regulations, I would stick with first looking at the official websites. So before you go to YouTube, which is what I do all the time myself, is look under OSHA.gov for the specific topic, and you'll find information there along with their YouTube videos, the National Chemical Safety Board's videos. There's a lot of great resources. So make the pitch for that. And with that, we'll finish with a short video. Ooh, we're gonna need sound, I think. Hopefully that's about right.
Accident? It's no accident. Company should have replaced that line years ago. I knew I shouldn't have reached over like that. And why isn't there strict policy about two people doing a job like this?
So there's a lot of things that are just like this. They seem innocuous, you do it all the time, maybe that's the way you did it at home all the time. It may not be the right way to actually do the job. So give these jobs, these tasks and these projects a little thought from a safety point of view. Talk about those issues you know you're gonna have up front before you start working for the day. If you're handling new chemicals, make sure you go over the first aid section on the safety data sheets. And obviously, if you have any questions, try those resources. And you feel free to call me. We'll be glad to help. So there's my pitch for operating your club safely. Okay?